I want to show you, well, I want to talk about asynchronous programming, but with Commodore 64. What do you mean Commodore 64? It could do that? 32 years ago? But wait, what the fuck is Commodore 64 anyway? Does anybody here knows what Commodore 64 is? Nice, everyone. So for those two of you who don't know, it's this beauty. It has a Guinness World Record for highest selling single computer model of all time. If that doesn't blow your mind, let me tell you about its features. It has 1 megahertz processor, 8-bit registers, 64 kilobytes of memory. It's 16 times more than anyone would ever need. This is like Bill Gates said that. And it's not produced for more than 20 years now. That's sad. But 50 new games were released last year. That blew my mind. Want to see why? Well, people love Commodore 64. I love Commodore 64. It was my first computer. I want to show you two things that blew my mind. So basically, my first program I ever written was look like that. Well, it was not PolyConf, but you know. So you can code in BASIC after like turning on the Commodore 64, and that's basically how I started. But now, like 1 year ago, I started doing something that I couldn't do when I was younger. I started learning Commodore 64 assembly, and I want to show you a program. Oh. Just a second. Okay, so this is a program written in assembly, and let me show you what it does. Just quickly, high-level overview. It cycles characters in the top left, in the top line, and cycles colors in the bottom line. And then there is a delay and loop going back, so it executes infinitely. But I want to show you something else. If we don't call cycle colors here, but instead we'll type magical incantation, we'll disable interrupts, whatever that means. We'll take the address of the cycle colors subroutine. We need to do it 1 byte by byte because we have 8-bit registers. Then we take these values and we put them into a place called interrupt vector. It should be stx. sty interrupt vector +1. You need to put it byte by byte. And then we turn on interrupts once again. And we need to change the cycle colors subroutine to not return from subroutine, but instead to jump into a place called interrupt address. And this is how we can inject our subroutine into something called interrupt handler. And if I type that correctly, it works exactly the same as before, but that's not the thing that I want to show you. Let's see what happens when instead of jumping to the loop, I'll just return from the program. Now, the first one doesn't run, obviously, but the second one, it is executed asynchronously in the background, so I can actually type. And when I discovered that for the first time, it literally blew my mind, and I fell in love in Commodore 64 again. And I'm pretty serious about that. And I'm starting a project. It's called 64 bytes. It's not bytes with Y, it's bytes with I. There are short and sweet Commodore 64 programming screencasts, and you can sign up for them, and I want to start this project this year. If you are interested, go to this website, sign up, and I'll let you know when it's ready. Thank you.
My name is Stępień. I'm originally from Warsaw, but some time ago I moved to Munich in Germany, thus contributing to the general trend of people from Warsaw moving to Munich. But let's skip football. Football is boring. Let's talk about bubbles. I work full-time as a Clojure developer these days. And as a Clojure developer, I try to look for some other inspirations from better languages out there. For example, Erlang. Erlang has this excellent, among any other things, excellent idea of live code reloading. Without any pauses, without downtime. I want to have something like that. The problem is that Clojure allows you to dynamically change code as you go, but it's not quite atomic in its behavior, right? If you reload the whole Clojure namespace, some functions might have been reloaded, some of them are still old. This leads to unpleasant race conditions, etc. I want to avoid that. And that's why my idea is, let's put the code in a bubble. This is a bubble. Into the bubble, I will load some of my namespaces. They are hidden there, isolated from the world, and I have a function called through. Through is a function through which I look into the bubble to get access to my functions, call them, etc. Now I want to reload the code. I take a new version of the code, load it side by side, the existing functions are there and still work. And if loading of the new code, if its compilation, etc. went fine, I just remove the old bubble and atomically make through function point at the new bubble. If everything in the process went wrong, exception was thrown, etc., I have the same state as before the operation has started. Now, a couple of important facts. Should you use it in production? Not yet. Do I use it on production? Not yet, but I use it on staging. It's all open source. It's all available. It's all on GitHub. If you feel adventurous, just check out the line again project. There's a dependency just to be copy-pasted from the slide. Try it out. If you feel like reading the code before you execute it and create idea, check out the GitHub project. Everything is there. And you've been a great audience. Thank you all very much.
Okay, so I'm Alejandro. I come from Spain. I work at a company called Kaleidos. We are a Madrid-based agency. We work for startups. We build their products, and then we move on. We try to not to maintain these projects, work continuously in new projects. And I would like to talk about a thing we do. It's called Pi Week. Every 6 months we stop for 1 week and just stop our ongoing projects and directly work in some of our own ideas. The next one is in December. You may want to join. It's open for everybody. So far, we have collaborated with Spanish companies, but it will be great to make this international. And I would like to mention one of the projects that we created during these Pi weeks is called Taiga. The website is taiga.io. It's a project management tool. It's a polyglot. The backend is in Django, and it's an AngularJS application. I'm not going to demo it because it's very Ajax heavy, and I don't trust the network connection, and also because I'm very nervous. English is not my first language. So yeah, check it out. It's in taiga.io, and you can see it on GitHub also, github.com/taiga.io. Yeah, check it out, and let me know what you think about it. Thanks.
Finally, yay. Okay, I'm done my job. Hi, my name is Irina. I'm a full-time Rails developer at Free Agent based in Edinburgh. So it's full-time Rails developer doesn't sound very exciting. And I want to share just a short anecdote on how you can use some algebraic methods that I've never thought I would need any time. So using Boolean logic to deal with dates for fun. The problem is parse a string to a date object. That sounds simple enough, except it isn't. The conditions are date could be in a format when month comes first before the day. It could be in any format recognizable by the standard date parse method from Ruby core. But it couldn't be in a format when the date comes before the month. So, for example, if it's the 1st of January 2014, it could be interpreted by the both formats, and it should be interpreted as the date, as the month first. So these are the 3 input variables, and so that's our input: month, day, year, generic parse, so the output of generic parse, and you can notice rescue nils. It's in case the parse fails, and we return nil. So it sounds like we have a Boolean function with 3 input variables. What can we do with it? We can build a truth table. I will skip all the meticulous steps of building it. I will just mention that X's indicate the inputs that are impossible. For example, if the second row is impossible because if it is parsable by day, month, year, it automatically is parsable by generic parse. So this is the impossible input. We ignore the output. So we build the truth table step by step. And what can we do next? Obviously, our goal is to form a minimal Boolean function to handle this date parsing. We can use a method called carnomap. Does everyone know what the carnomap is? Okay, someone does. Perfect. So the carnomap is a neat graphical method to simplify and minimize Boolean functions. What do? We basically rewrite the same truth table, but in this funny format. So on top are the values of first 2 input variables, and sideways, like the rows, are the values of the 3rd input variable. We can build this with any number of inputs. We rewrite this truth table, and then we try to find, on this table, we try to find the groups, consecutive groups of 1s and x's. Actually, you can either include or exclude x's as you wish, whichever works for you. For the particular case, I decided to include them, but you can do it not. So the conditions of the groups are that they should be the size of the degree of the 2, like they could be the size of 1, 2, 4, etc. So that's the first, and you should find the largest possible group. So the largest possible group of consecutive 1s and x's is this one. The second one is this. And the third one is this. That's it. We can't find any more groups. Then what we do next? So we see at this table, we try to find which variable doesn't change in the whole group. So we can see that both generic parse and day, month, year can take either 0 or 1 values in this group. But month, day, year doesn't change. It's always 1. So we just write that variable. Next is this group. We see that generic parse is always 0, so we write not generic parse. And day, month, year is always 1, and month, day, year changes. So we write the next group is not generic parse and day, month, year. And the third group is generic parse is always 1, day, month, year is always 0, month, year changes again. We write this generic parse and not day, month, year. As someone might notice, if I just excluded the second group, it would be pretty much the same. So it doesn't, with our inputs, with the inputs we care about, the total value of the function, the total truth table of the function won't change. So, and that's it. That's the most minimal Boolean function we can build to parse the date following this peculiar requirements that that the date is only valid if it can be parsed by month, day, year format, and it is not in day, month, year format. This is the final Ruby code to produce this function. To be honest, it was in production for some time. It's not very descriptive, and eventually you shouldn't do that. I changed it to something more well-commented and more intention revealing, but still that was a funny exercise. Thank you.
Hi, my name is Michael. I want to speak about secure by default. You can find me on Twitter, on Gmail. So I was wrong. I thought I knew that all the measures of security that we can apply, they are wrong, that it's always something that can be fooled, and you cannot apply more security. You can only try. And I was wrong. You can actually try to do better. And you can prove that code committed or released was actually written and released by this person. So there is PGP and GPG. So PGP, pretty good privacy. It's a standard that describes how do you generate keys that allow you to sign and verify code. And GPG, it's GNU PG in short, or GNU Privacy Secured, which tells you, which it's a tool that implements PGP. So a simple command to generate your keys is GPG gen key. It will ask you some questions. You can generate a key that you will use for signing. The first thing you can do is to export the public part of the key with Armor, which gives you a text version of the key, and export to print it. You save it to file by redirection, and Papis ASC, it's the file name. This file, you have to distribute it a secure way. Internet is not secure, so you have to give this file manually to as many people you can, or verify with them that that's your file. Then, when people have your public key, they can verify any file you sign that it was actually signed by you. So how do we sign? We sign it again with Armor to get the text version. Detach sig, it's just a signature. So we have a file name, and we want to produce signature for this file. And you could just sign the file, but then the signature and the file will be together in one file. So we want to produce separate file for signature. So we use detach signature and for file name. Now, anyone that got our key can import it and verify by the signature that was generated, the ASC file name. And that's all. Thank you.